Okay, next for this example number 6. So we have to find the time response specification and sketch the output response of the closed loop transfer function. So given closed loop transfer function Cs over S equal to 20 divided by S square plus 5S plus 16. So to solve this, so we have to compare this transfer function with the general transfer function for the second order system. So when we compare, we know that this component is referred to omega n square. So omega n square in this case is equal to 16. So from there we can calculate omega n, where omega n is equal to 16 equal to 4 radian per second. Okay. So next, this component 5 is referred to 2 zeta omega n. So based on this formula, 2 zeta omega n equal to 5, so we can calculate zeta because we already know this omega n. And based on what we calculate before, we just put this value here and then zeta is equal to 0.625. Okay, based on this information, we know that the system is under damped case. Okay, from this value of omega n and zeta, we also can calculate omega d. We just put in this equation where omega d equal to omega n times Z1 minus zeta square. So we just put both value here and then we get omega d equal to 3.12 radian per second. Okay, for time response specification, we have calculate TS, TP, TR, and also percentage of overshoot because this is under damped case. And that's why we have to calculate percentage of overshoot. Okay, to calculate TS, we just use formula. So basically, we use normally we use formula for the 2% criteria, which is 4 divided by zeta omega n. So zeta omega n we already know, zeta we already calculate, omega n we already calculate. We just put in this equation and then we get Ts equal to 1.6 second. Okay, for Tp we just use formula pi over omega d. Omega d we already calculate here and then we just put this value here and then we get Tp equal to 1.01 second. Okay, for Tr we just use this formula. Okay, and then the result becomes 0.488 second. Okay, percentage of overshoot. Okay, this percentage of overshoot is only depend on the value of zeta. Okay, we just put this value in this equation and then we get percentage of overshoot is equal to 8.08%. Okay, so how to sketch the output response? So first we have to draw like this and then we have to draw just sketch the response for the under damped case like this. Okay, so after that we just identify which is TS, TP, and overshoot. So TS, TP, overshoot, TR we already calculate here. We just put TS here. Okay, we just label this one is equal to TS. Okay, this value. Okay, so TP is referred to the overshoot. Okay, the peak value. So this value refer to TP. Okay, TR is the value start from 10% to 90% of the final value. So this is the final value. So we just put all these parameter. We just write all these parameter in this graph. Higher order system. So a system is known as higher order system if the number of poles of the system is more than 2. For example, we have 3, 4, 5 pole and so on. So no specific formula can be used to analyze the system. However, the formula used to carry out analysis for a second order system still can be used provided that the location for the third pole and the rest of poles are situated more than 5 times further away from the dominant poles. So what is dominant poles? So dominant poles is refer to the poles situated nearby to the imaginary axis that can influence the performance of the system. So for example, this case and this case. So this is we call dominant pole. where these two pole, this one and this one, this pole will influence the performance of the system. And also same for this one. This pole will influence the performance of the system. Okay, this pole depends. Also, this pole is also depend. How far this pole from this dominant pole. So for this case, so as you can see here, so the distance between this pole and this pole is about 3 times further. So this location of pole, this system with this location of pole, we cannot consider this as a second order system because this location of third and fourth pole is close to the dominant pole. So this third and fourth pole will affect to the performance of the system. Okay, but for this system with this location of pole, so this system we can consider as a second order system because this dominant pole and this third and fourth pole, the distance is 7 times more. So that means this system, only this dominant pole will affect the performance of the system. Okay, before we end, let us look at the summary of this chapter. So first, the poles and zeros of a transfer function can determine the response of a control system. Second, the performance specification for first order system is the time constant, which determines the speed of the system response. Okay, next, second order system can have 4 types of response, which are overdamped case, underdamped case, critically damped case, and undamped case. Okay, next, there are 6 performance specifications associated with the second order system that are damping ratio, zeta, natural frequency, omega n, percentage of overshoot, peak time, Tp, settling time, Ts, and rise time, Tr. Last one, higher order system with the third pole and rest of poles that situated more than 5 times farther away from the dominant poles can be considered as a second order system. Okay, thank you.